सो हेलो स्टूडेंट्स, आज हम देखने वाले हैं एक्सपेक्टेशन वैल्यू। सो व्हाट्स एक्सपेक्टेशन वैल्यू? सो व्हाट इज द मीनिंग ऑफ दिस? देखिए, एक्सपेक्टेशन वैल्यू मीन्स होता है आपका किसी भी चीज़ का एवरेज वैल्यू। ओके, so in quantum mechanics, whenever we see the expectation value, find the average expectation value of this operator and something else, that means we have to find the average value. And what type of average value we have to find? This is the weighted average. Okay, in mathematics, we see in the basic classes like 11, 12, the what is the weighted average. So we have to find the weighted average same as in the basic classes. Okay, so now we are going to quantum mechanics. So let an operator A. We are saying this operator A is measured on an identical system, and it is giving us the eigenvalues A1, A2, A3, and like an. Okay, these are the eigenvalues if the A operator measured on the like an identical system. And we know that finding the eigenvalue A1, we have the probability P1, P2. Correspondingly, we have all the probabilities are like this. Okay. Now, what is the expectation value? So expectation value, and the sign is this. This sign is the average or expectation, you can say. So what is the formula of this? This is same as the weighted average. So what we will do in that classes, I think. So there is the formula like probability into that eigenvalue, or we are getting the result whatever we are saying it here eigenvalue, because this operator after applying on any eigen state, this is giving us a eigenvalue like this. Okay, so we are saying this is a probability and this is eigenvalue. So A1 P1 into P1, like eigenvalue into that probability plus second eigenvalue into second probability, like all the sum of these things, and denominator is the sum of probabilities. Sum of all the probabilities. It is the expectation value of an operator in the basic meaning. What is this? This is weighted average of the eigenvalues basically. Okay. Now, if we are saying this our eigen function is combination of some small like is the wave function, so that is like c1, psi1, c2, psi2, all these things. Okay, so I can say this is basically the eigenvalue into probability. So sum of ai pi, we can say that it is the sum of eigenvalue corresponding to that probability, okay, into that probability, and I goes from 1 to n. Denominator also same thing, and there is no eigenvalue, so pi and summation I is equal to 1 to n. Now for any system, if the wave function psi is normalized, we know the corresponding probability of this wave function, the total probability should be, the sum of probabilities should be 1. Okay, so we can say directly that denominator part is 1. So our average value of an operator is basically summation ai pi and I from 1 to n if there is n substates. Okay, this is the average value formula. But how we are finding the average value in the like wave function form and Brown gate form. So we are converting it as this, like we can say a operator, average of a operator is equal to psi and a and psi divided by, we have the summation of probability. But if that is not equal to 1, so we are writing it also that normalization of that wave function like this. Okay, this is also the average of wave function. If you're not getting this, how we are getting this? So you can write the probability here and applying the eigenstate again, so we will get the same thing here. Okay, this is in the wave function form like gate and bra form. If the wave function is in the sine or cosine form, like basically trigonometric wave function are there. So for trigonometric wave function, the formula will be different. Okay, like we have the same thing will be in there also, but the writing thing is different. So what is the sine? Is sine in the integration form, we are writing minus infinite to plus infinite limit, and this like bra sine is equal to sine star and a operator, and sine get sine is sine and dx. This is in the denominator, and in denominator only the normalization part is there. So sine star and sine into ds. This is the probability in the trigonometric function. Okay. If the function is normalized, then the denominator is equal to 1 in both cases. Okay. If the function is normalized. Okay. Now this topic is completed, but we are saying that we are taking an example to find the expectation value. How you see the exams in the NET exams, this is asked in many times. Find the expectation value of these things and this. So and there is an example I'm taking. Let's see example. So example is that you have a wave function psi, and the combination of two sub-wave functions like 1 upon root 2 and u1 minus 1 upon root 2 and u2. Let's see, this is given. Now, you are saying that u1 and u2 are the basis of this wave function sine. Now, we have said that corresponding to these wave functions u1 and u2, we have the eigenvalues like e1 and e2. It is given e2 is given something minus 2 electron volt and e1 is given minus 1 electron volt. So now it is asked that find the expectation value of energy. So basically the expectation value formula is the same. Here the operator is E operator. E operator means energy operator will operate on the function and giving us the energy eigenvalue. So what we will do? First of all, we will check this wave function is normalized or not. If that is normalized, that's okay. If that is not normalized, you have to first normalize it because that part is easier. Okay. So sine is basically 1 upon root 2 u1 minus 1 upon root 2 and u2. So how we will check this is normalized or not? Basically the formula is that this is c1 and this is c2. If c1 square plus c2 square is equal to 1, it means that this is normalized. Okay. So let's check. C1 square means 1 upon root 2 square. 1 upon root 2 square plus minus 1 upon root 2 square. And this is equal to 1 upon 2 plus 1 upon 2. And this is given as 1. Now, we understand that function is normalized. Now, wave function expectation, like energy expectation value is equal to summation probability of state first and like I, you can say I, pi, and operator is di. So we are saying that p1 e1 and p2 e2, because denominator part there was summation of phi, but here we know that function is normalized, so we should not write this thing. Okay, that should be 1. This is 1, so that will not affect your answer. Now probability, basically the probability is the substate coefficient square. Okay, so basically here the probability of the first state is 1 upon root 2 square, second state 1 upon root 2 square. In the both cases the probability is 1 by 2, meaning is this. Okay, so how we will write this? 1 upon root 2 square, and energy eigenvalue for the u1 is given minus 1 and u2 is minus 2. So we are saying minus 1 plus 1 upon root 2 square minus and into minus 2. So this is 1 upon 2 into minus 1, and this is 1 upon 2 into minus 2. Okay, so finally our answer becomes minus 1 by 2 and minus 1 is equal to minus 3 by 2 electron volt. So this is our eigenvalue, energy eigenvalue. Okay, so this is the way like you have to find the eigenvalues of that like any type of operator. Okay, I'm taking another example, so you can try it at your own. If you have any question, then you can answer. Okay, so example 2 I'm taking for the next formula, which is integration formula. So at this time you have to ask like average of x operator and average of position of momentum operator. Position and momentum you had asked. Okay, so psi is given here root 2 by L and sine pi x upon L, and the limit is given 0 to L, and otherwise it is wave function is 0. Otherwise this is your question. Okay, these things are asked. Now, what is the way? The thing is same in here also. Like how we will find the x operator average? So basically, we will do psi star and x and psi and dx. You can integrate it and check that it is normalized or not. So I'm saying it is normalized. So it is your responsibility to check it. Okay, check normalization. Okay, you have to just integration psi star and psi. For the real wave function, like psi star and psi are the same thing. So you can directly say integration of psi square in the limit of minus infinite to infinite. Okay, check it. Minus infinite to plus infinite and this. So I'm writing it again. Psi star and psi. So root 2 by L into root 2 by L. You will get 2 by L outside. And the limit is, because minus infinite 0, it is wave function is 0. And 0 to L, wave function is only surviving in the limit 0 to L. So we can say directly 0 to L. And x, this is sine square pi x divided by L from 2 dx. Okay. Now, what we will say? We will do one thing here. We know the sine square theta is equal to 1 minus cos 2 theta divided by 1 minus cos 2 theta into divided by 2. Okay, this is the way from the formula of trigonometry we will use here. We will put the sine square theta as in the cos theta form, because for the integration we don't know about the sine square theta integration. So we are changing in the 1 power form. So this will convert in there, and 2 is cancelled when we put this thing. So we'll get 1 by L 0 to L x into dx, because x is multiplying on 1. Okay, x dx minus, and the second thing is x cos 2 by x divided by L into dx 0 to L. So basically now our integration will become like the first part and second part. If you will solve, the first part is basically L square by 2, and the second part is, this is the odd function, odd, and this is even. So our integration will be 0, basically you can say. And you can check also. Okay, so this is 1 by L into L square by 2. So our wave function like position operator average value is this L by 2. So we can say this is x average. So in the second part, we have asked the position like momentum operator average value. So you can find it as the same as this we have done in the position operator. Okay, so I'm writing the answer directly, and you can check at your own and comment me that the part you are getting is same or not. Okay, the answer should be 0. Okay, for the hint, I'm saying that momentum operator and average, to find this average we want momentum operator. So what is that? This is minus iota h cos del upon del x basically. Okay, this you will use and you will get the answer.